like this to the 95. ऑलरेडी लॉग इन कर रहे हैं स्टूडेंट वेरी गुड
तो ये चार्ज लगा ना एक चल क्यों नहीं रही है
We'll start now, madam.
Okay, just wait for 2 more minutes. 2 more minutes. Just wait for Oh, madam, 20. She is not. She has already done. Mine is mute now.
Mute. Dr. Rajamalli, you ready, right?
Yeah, I'm here.
Yeah. Professor Deepti?
Yeah, I am here.
Yes, Deepti. Let's start. Good afternoon, one and all. So now we are the verge of our webinar. So this is the fourth session of our webinar. So we have with us distinguished professor from IIT Bombay, Professor Deepti, and I request Professor Rajamalli from IIC Bangalore to introduce the speaker.
Yeah. Oh, hello. Thank you, Shubham. Yeah, it is my pleasure to introduce Professor Deepti Gupta. She has completed her bachelor degree as well as M.Tech and PhD from IIT Kanpur. Later, she moved to KAIST and she worked as a postdoctoral fellow there. And then she moved to Imperial College of London and she worked as a EPSRC research associate. Then later she moved again to Korea. She worked as an assistant professor at Seoul National University. And then after that she joined IIT Bombay. And she is also recipient of ACRB Power Fellowship. And she has received many awards and also many grants. With this brief introduction, I'll invite Deepti Gupta to take that. Yeah, please go ahead.
Yeah. Thank you, Professor Rajamalli, for the introduction. And thank you, Professor Shiv Kumar, for inviting me for this talk. It's really my pleasure to speak before the audience and all your college staffs and students. So very nice coming over here. So I'll now start with my presentation. So let me share my slides. So is it visible to you?
Yes.
Okay.
Yes.
So yeah.
You got it. Yeah.
All right. So the title of my talk is Product Innovation in Human and Machine Health Monitoring. And basically, like I would like to go and tell you my journey of how we will do translational research. And since translational research is something that everybody is talking about in India these days, and it's need of the hour, because as you know that we in Indians in general, like not all, but generally we are very good in knowledge creation. We understand theories and do lots of things in understanding the topic, but generally we are not able to convert our knowledge to wealth or creating some kind of useful products. So, and this is a need of the hour, and since last 8 to 10 years we are trying to come up with the whatever research we are doing, we are trying to now see that how our research can be converted into something useful. And this is a long journey. We are still at a very nascent stage, but hopefully whatever we are doing, probably you will get some ideas from there or maybe some inspiration from there and try to incorporate that in your research and work as well. So basically, I would be talking about innovation and product innovation basically. And I will take two use cases from my research group that is about human and machine health monitoring. And these topics are very relevant, like human health monitoring and machine health monitoring both have the same kind of a philosophy, that you do not want to go to a stage where nothing can be done. You don't want catastrophe to happen, right? You just want to prevent it, right? And as you know, that's a famous proverb, prevention is better than cure, right? So you do not even want to go to a stage where you need to take drastic measures to recover what you have already done. It's better that you may take preventive action so that you don't reach the catastrophe stage or do something where you are not able to come back. And in this case, like it applies to both human and machines. In humans, like you do not want to fall really sick or go to a stage where your condition is really deteriorated, right? And you are not able to do your things in your daily life well. The same goes with machines, like machines and basically industrial machines, or even any kind of a machines. More useful when you talk about industrial setups, because you have lots of machines, and even if one equipment or machine goes bad, then it causes huge cost to the industry, right? So even for machines, you just want to take preventive measures so that they don't suddenly go to failure stage and nothing can be done at that moment. So I'll take how we are addressing these two cases over here. So let me first, just to set up the background, I am actually showing this slide in almost all my presentations these days, because this is something really important and everybody is talking about these days in India. So first of all, what is innovation? And before I say what is innovation is, because we know invention, right? We lots of time talk about lots of inventions has been done, but innovation and invention actually are not the same thing, right? Inventing is that you are coming up with something really new. For example, if you see this picture over here, Edison has come up with an idea of, for example, bulb, right? How one can create a bulb, right? Or but then converting actually into a bulb is something he has done. So he has done invention and innovation both, right? Coming up with an idea and converting them into something which people can use, right? So innovation basically is that you have to convert them into an idea which people can use, and basically by definition it says that it addresses a specific challenge and adds value from a customer's perspective. And it is important to mention here customer's perspective, because ultimately whatever you are building, somebody is interested to buy, right? Because they find like value in it, and therefore they would be buying it, right? So it's like this way, that suppose you have invented something new, you have come up with something new, but if you are not able to convert them into something useful, then it's of roughly of no use. So whatever inventions you have, if you are converting into a product, that process would be called an innovation, and therefore you are able to create lots of value of your invention, right? So in economic terms, if you see, so it is like this. In invention, mostly you have to have net money flowing in, right? Most of the time you have to invest lots of money to get some output out of it, or some invention out of it. And in India, basically this is happening mostly from the government funds, right? So lots of money is going in and lots of inventions are coming out. And now if you are able to convert that invention into innovation, that means something useful product, then lots of people are using it. So there is net money flowing out as well. So out of your invention, you are able to create money out of it. And therefore, again, once there is some money coming out of it, you again can invest into creating new invention. So this, in this model, you are you create a sustainability. This is a sustainable model, because you are continuously into this cyclic process. You are continuously doing invention, it is converting to innovation, and always whatever money you are investing in, it's in innovation, more than whatever you invest comes out, and therefore you are again able to do some more innovations, and lots of new things keeps coming. Unfortunately, in India, we are mostly in this stage, in invention stage, right? And innovation is very less as of now. So whatever investment has happened, it has not created any wealth. But now is the time that these are actually getting converted into innovation, and money needs to flow out and then feed back to innovation, invention again. Right, so continuously we cannot depend on the government grants without creating any value to our invention. So hopefully by this slide, the idea of invention and innovation is clear to you. And this is how people do product innovation process. And I have taken it from courses like design thinking and product innovation. And this is a very common slide that people shows that how one can actually do product innovation. how people, what is the path that they follow. So first stage into this is empathize, right? Empathizing with the problem, right? Knowing that there is some problem. So first you identify that there is a real problem out there, right? For example, you do not have clean water somewhere, right? You do not have a clean drinking water. So and you know that people nearby are suffering from it. They are suffering from lots of disease because they are not like having this clean drinking water. So you first empathize that really there is a problem, there is no supply of clean drinking water in that place. So you now have to come up with an idea how to solve this problem, right? But then before you actually start solving it, you actually have to define what is the problem, like what is the problem. So why they are not getting this clean drinking water? There are lakes and ponds in that area, right? Then what is the issue that they are not able to get clean drinking water? So probably the issue is that somebody is disposing sewage or waste into that into those water bodies, and that's how like you are not able to get clean drinking water, right? So will you try to solve this problem, that let people not dispose waste into the water bodies, or will you try to solve this problem that we need to clean this dirty water, right, which is being getting dirty because people are flowing waste to it? So you have to define, like based on the situation, you have to clearly come up with a problem. What is my problem? So for example, there are lots of industries around that area, and they do not find sufficient place to dispose their waste, right? And they have no other means. So if they dump these things into for example somewhere else, then it would create another kind of a problem, right? So you need to come up with what exactly is the problem that you have to attack, right, that you have to handle first. So clear cut definition of my problem, which would give best outcomes, should be very precisely defined. And problem identification, in fact, people who are doing research, as you know, you are being told that you have to do literature survey, right? Literature survey is being told to you, like to all the researchers, so that you can get an idea of the background and find what is the clear cut gap that you can fill in, right? So finding a suitable problem, identification of the problem itself is a big problem, right? And people who are able to identify those problems, they themselves have done a very nice job, because once you precisely come up with the problem definition, you will be able to find much better solutions. Vague problem definition will also lead to vague solutions, right? So this is very important. Definition of the problem itself is very important. So come up with and you can apply these concepts in any area, whether it is research, your general life, or whatever, like or product innovation. But this is generally the flow of process, right? So problem identification is very important. And once you know that this is my problem that would lead to really good outcomes, then you try to think about it, like you ideate means that you try to find ways to solve those problems, right? So once you identify the problems, you list down 10 different ways to do it, right? 10 different ways to solve that problem, right? Do lots of analysis, keep coming and going, like which one would solve the problem best. Or suppose there is no best solution, maybe 2 or 3 mix of the methods would give you the best solution, something like that. So you do ideate and do analysis, and then find a way to solve this problem, right? And then in this process you will be doing lots of methods, analysis, innovations, right? So once you do that, after doing this, you will come up with some kind of a prototype of the solution, whatever it is some device, it is some method. So some prototype solution you would be coming up with, right? And then you will test it, right? So because you will test in the real field, and you will try to test on those areas or peoples, whatever it is, whether my solution works on it. So field test, rigorous testing on the subject is very important, right? And then if you don't think that people have given or good feedback about your prototype, you again have to repeat this entire process, right? Probably you had not empathized with the problem really well. So you had come up with a prototype, but when you have taken it to the field, probably it was not as effective as you have thought, right? So you again go back, again try to understand what was my issue, why didn't it do the job, and again try to solve this process and keep doing it until it is accepted by the people or the society, or you have attacked the problem really well. So this is how, in fact, all the people do it, keep repeating, keep fine tuning their methods. In my journey for translational research, as I mentioned, I would be talking about two use cases, and basically this is about diagnosis and prediction. And in human health monitoring, I'll be talking about remote and continuous monitoring. And basically, specifically, it would be wearable sensor, for example, blood pressure, ECG, EEG. And in machine health monitoring for Industry 4.0, I'll talk about low-cost vibration sensors. So let us talk about human health monitoring. So I'll start. How have we started doing getting into this health monitoring? So when I was doing my PhD, since my PhD, I was working on organic electronics area, and I had worked in my PhD and mostly in postdoc as well on thin film, organic thin film transistors. So by that time, I really knew about this technology. We had created lots of different kind of transistors, and they were flexible, stretchable, soft, and lightweight. Right. So this was a core technology that I had at hand. But the problem when I had joined IIT Bombay after 2 years, this problem was posed to us, and it was a Indo-US grand challenge on cuffless blood pressure monitoring. Right. And so they had called us, they had called for a grand challenge, and they wanted to create this, develop this cuffless blood pressure monitoring as a proof of concept. And what is the importance of cuffless blood pressure monitoring? Because it allows you to have continuous monitoring. The way to regularly measure the blood pressure, like you do, like you put cuff around it, and then you like dilate it, you squeeze it, and then doctor see your blood pressure values. So the regular way of doing it would not allow continuous monitoring. And the importance of continuous monitoring is that for many critical cases, right, many people who have cardiovascular issues, right, they are very much prone to have heart attacks. And in heart attack, you know that time is very critical, right? So even like 10-15 minutes before, if you come to know that the patient is going to have this heart attack, you can take preventive measures, right? So for that purpose, you need to do continuous monitoring. For like long term monitoring, you have to do on critical patients, so that you can save their lives. And in fact, people say that if you can early predict, and then in 80% of the cases you can actually save the life of the patient, right? So it is therefore very much important, and such kind of devices are required, right? So we had tried to convert this organic thin film transistor technology into a blood pressure monitoring sensor. So what we did was that we did try to improvise towards the dielectric side, and we applied pressures, and we could see changes in its transfer characteristics. Right. So this was one of the one of the very simplest measurement that we did. But then it involves lots of different kind of microfabrication techniques. You have to apply lots of modeling, and lots of, like, it's in a very nascent stage. Again, lots of trials and clinical trials testing has to be done. But in this process, we have also developed very nice organic thin film transistors that are low voltage and high mobility. We try to use this, and we try to improvise through this dielectric side, which is this is a trademark material from Dynacell, and it's called Siva 110. And we try to use it as a dielectric material. And what we saw is that it gives us very high capacitance. It shows very good dielectric properties for the transistors. And because of this, we created very nice transistors using pentacene, and threshold voltages were really low, of the order of 1 volt. And mobilities were really high, around 2 centimeters per volt second. And 2 is something really good because in organic material generally very high, you are not able to get very high mobility as compared to silicon based transistors. Then we also tried to simplify process because we thought that transistor based methods processes become really complex, so we thought that we would convert them into a simple capacitive device, and this is the simple capacitive device that we had made, which is microfabricated, and dielectric was microfabricated over here. And this simple device, as you can see, that it even this simple device gives us very nice pulse wave, and you can see the features of it like P1, P2 and P3 are still you can see very nicely. But still we wanted to make processes even more simpler, and therefore we thought that we can take now a nanomaterial based approach. And in this process, we have tried to come up with low cost piezoresistive pressure and strain sensors. And our approach was that since anyway you might have observed that in the last dielectric, it was you are creating a dielectric and air gap kind of a structure. So we thought instead of creating those structures, why not take something which is readily available and it has a porous structure in, for example, foam-based structures. And we selected polyurethane foam-based materials. It has a porous structure. And first we tried to create a capacitive device out of it, but we found that it was really high voltage device. So we tried to convert into a resistive device. And in this process, we had also created this ink, which is reduced graphene oxide and multi-wall nanotube based ink. And this ink has very good properties in terms of dispersion, wettability, and I think cost would also be low. And it can like wet any kind of a surface. So we just dipped our PU foam material into this ink and put two electrodes on two sides of it. And then we tried to fabricate the device and did all these electromechanical tests. And this is a simple operation mechanism for this device, because once this ink, conductive ink, is integrated into this exoskeleton, and once you apply pressure to it, all the conducting parts come together, and hence your resistance